Hello and welcome to another Kubla tutorial. In this one we're going to look at adjusting your projects to accommodate for material thickness, so getting your elevations that you've taken off from finished floor levels down to the subgrade or formation level. The scenario is when you take off elevations from a site plan like this one, you'll find that on the site plan is almost always marked the finished floor level, whereas as an earthworks contractor you actually want to calculate to the subgrade or formation level. The problem with just adjusting every value that you take off from the site plan to accommodate for that is that first of all it's nice to be able to see the value that you've taken off matches the value that you can see on the plan, and if that's not the case it can get quite confusing. Secondly, the material thicknesses can change during the design phase of the project, so you wouldn't want to have to go back and change every single contour that you've taken off to adjust for a paving thickness. So instead we're going to look at two different ways of doing it in Kubla Cubed. Okay, so the first method we're going to look at we call the offset method, and that's because we use the Z offset in a earthworks element to adjust elevations to the subgrade. So to get that Z value to appear, you have to change this defined box to levels and offset. So by default it's just set to levels and has no Z adjustment box, but if you select levels and offset, a offset Z appears. And if we enter a negative value here for the thickness of the material layers, then that will adjust that particular earthworks element to a subgrade. So if we put, for example, minus 0.3 for the approach road, that will drop the road down by 30 centimeters. So this works in projects where you have the project split up into different earthworks elements for different areas of material thickness. So in this one, I've got an approach road, parking lot island, a ramp, building pad, and building pad reinforced. And each one of those has potentially a different construction thickness. So we'll go through making those adjustments. So the approach channel's been dropped down minus 0.3. We'll do the same for the parking lot. However, with the parking lot planting island, we might change that by a different value. So we might do, for that one, we might do 0.4. And then we'll do 0.3 for the ramp. So you can see how you just go through, and each area that you've got with a different construction thickness should be represented by a different earthworks element, and then you can just make that adjustment in Z. So it's minus 0. I'll do this one minus 0.3 as well. This is a metric example, so these are like in centimeters. So getting onto the building pad, it's actually been represented by two different platforms. So if you watch the video on calculation order and construction phases, you'll know that if you have two earthworks elements overlapping in the same phase, then the one lower down in the calculation order will effectively overwrite the one higher up if they have explicit elevations, like for instance platforms. Spreads and strips work slightly differently, but elements like platform, slope, path, feature surface and triangle surface will effectively overwrite each other because you can't have two different proposed elevations in the same phase. So in this example I've got a larger part of the building pad as one platform, but then I've overwritten a section that we want to reinforce. Now they both have the same finish level, 1282. So in the 3D view at the moment, they both look like just a single level area. But the reason I've done that is because I want to adjust them by different amounts for the subgrade. So using this kind of method of overwriting different sections with different earthworks elements, you can create quite complex designs with different construction thicknesses. So in this one, I'm going to drop this one down by 0.35. And you should see in the 3D view when it calculates that that part of the platform drops down, but the reinforced bit stays where it is because that hasn't been adjusted yet. And then I'm going to adjust the reinforced part down by even more, so 0.6. And you should see that drop down lower than the rest of the building pad. So another thing I should mention with the areas inside other areas is it's worth setting the batter slope, which is the batter of the side slopes, to 0.01, because these elements have been used to define different areas of construction thickness, but you don't want a side slope view there. You usually want that vertical. So that would be true for the building pad reinforced area. I've set the side batter to 0.1 and 0.01, and I'd also do the same for the planting island. Set this to 0.01. So that's the offset method basically. It's always worth validating the data that you've input. So I'd say the best way to do that for this is, opposed to going through every element and checking all the data, you can go File, Create Spreadsheet, use the input data, and you can see all the earthworks elements and the offsets that you've entered. Another thing that you should do is, aside from viewing it in 3D as well, is looking in the design view, hovering the mouse over the different areas and checking that the ZP is now what you want your subgrade to be. So that's the offset method in a nutshell. The reason that it can't always be used is often you have a site plan which will have all the proposed grades as one set of contours, and splitting it up into different chunks can be awkward. So to take this site plan as an example, what we have here is a standard setup where we've got the existing defined by dashed contours, we've got the proposed defined by solid contours, and then we've got 3 different areas where we have different material thickness. Here it would be difficult to break the site up because the elevations aren't specified for different areas. There's elevations specified for the whole site, and we want to smoothly interpolate between those contours and then make adjustments from that. If we tried to break it up, we could end up with like jagged edges because the different sections could not include the contour information that we need. So what we'd do in this case is actually try and take off all the proposed as a single feature surface and then make adjustments using the strip element. So this method is called the strip method. So I've loaded this site plan into this project to demonstrate. To quickly go through it, we've got the existing surface there that we've taken off from the dashed contours. Then I've done a site strip over the area that we're going to be working on. And then we've got the bulk earthworks, and all the elevations, which includes contour lines and points in this one, are contained in a single feature surface. So if we go to Edit Surface and turn off the site plan, you can see that we've got all the elevations there for that surface. So now we need to go about using the strip method to adjust the various sections for different construction thicknesses. So if you click on plus and select the strip, you'll notice it says topsoil strip and also construction thickness, because it's for these 2 different jobs. So if it's drawn over just ground, it will adjust the ground. But if it's drawn over another elevation element, like say the platform slope, it will adjust that element's elevations. So to quickly demonstrate, if I draw a strip over this pump house, it will actually adjust the elevations of that from the feature surface down by the default, in this case is 1 foot, but we can change that. So as you can see, that little section's been adjusted. So when using this method, there's 4 things to kind of bear in mind that you really need to pay attention to. So the first one is that the strips need to be in the same phase as the elevations you're adjusting. You don't want the strips in a separate phase to the elevations, because they need to be acting on that feature surface elevations, and then for the cut and fill to be done from that. As we know, all these elements are combined into a single proposed surface. If we put the strips in a subsequent phase, it would have a different effect and result in different volumes. So that's the first thing to remember, that the strips need to be in the same phase as the elevations they're working on. Secondly, you need to make sure that the strips must be below elevation elements in the calculation order. So when these are combined together, the ones lower down have precedence. So if the strip was above the feature surface, I'll quickly demonstrate, it would result in the strip being completely overwritten because the elevations from the feature surface would take precedence. So for that reason, it's important to make sure that the feature surface is above the strip in the calculation order. So going on to the next thing, it's worthwhile setting the side batters to 0.01, because when we're doing these adjustments, we don't usually want side batter. So I'll quickly do that here. I'll adjust this one to 0.01. And finally, when strips intersect, when you're doing these strips and they intersect, it's worth being aware that the effect will be cumulative. So if a strip is acting on a strip, the point where they intersect will be, say this one's 1 foot and this one's 1 foot, the point where they intersect will be 2 feet. So we can go into 3D and see the effect of that. So usually it's worth like just having them not intersect rather than having this situation where you have 2 strips and one of them has double the impact in this scenario. So that's the strip method. I'll just quickly take off this area and adjust it by 3 inches. So as way of example, so I have to do this quite quickly, and we'll go there. Obviously, if I was doing this properly, I'd spend a bit more time defining the outline, but so in this project we'd go for each of those different areas, we'd define a different strip and make that adjustment. One thing to know is that you can also name strips. So in this case, might name this to, I think it was this one was called gravel surfacing. So I could name this to, and change that to gravel surface. Name that to gravel surface adjust. And this is quite useful for the purposes of the report. So I'd rename those two as well. And we will set the depth here to 0.25, 3 inches. And we'll be able to see in 3D that that section has now been adjusted by 3 inches for that to that subgrade. So that's the two methods. I would recommend using one or the other. You can use both, but it can get quite confusing. So if I'd done this section with an offset and I'd done this section of a strip, when it comes to looking at the reports, it gets quite confusing if you've used the two different methods. So with using the strip method, to see what strips you've got, if you go File, Create Spreadsheet, User Input Data, you can see the strips listed here and you can see the depth that you've entered in. Another thing that's quite useful in this report is you can also see the boundary area 2D for each of the strips, which you can go on to calculate the material thickness. So if we go back to this image, we might actually need to calculate the material layer volumes as well as the subgrade cut and fill. So if you need to do that, you can do it in a separate spreadsheet by taking the areas of each of the strips and then multiplying them by the thickness of the material. Another way to do it is to create subsequent phases and use the spread, which is the opposite of the strip, and cover the same areas or strips, and then those spread elements will give the volumes of the material. So I'll just demonstrate with this area that we previously did. So if I go to this design view and I take the gravel surface adjust, click on that, so I've selected all the points, and then I do Control-C to copy. I go into this one I've called Proposed 3 here. I might rename it to gravel material. And then I'll create a spread. You can just create it anywhere because I'm going to overwrite the positions. So click on that top corner and then Control-V to paste. And I'll set it to the same height as the strip. So it's 0.3. Again, 0.25 for 3 inches. And I'm going to set, so it's important to set the batters to 0.01. Just double check that I've done that on the bulk earthworks. So I don't think I have here, so 0.01. And so to quickly explain what's happening here, so this strip, this is adjusting for the gravel surface down 0.25. So you can see that in the thing. So in the report, we will actually have a cut and fill of the features with that section adjusted to the subgrade. Now in this phase, we have the spread over the same area with the height counteracting the depth that we specified with the strip. So it basically does the reverse. And that means in the report, we're going to have a fill volume for that material here. So you can keep creating more phases for different materials. So that way you can have your cut and fill of your bulk earthworks with the strips adjusting to the subgrade, and then fill in those materials using spread elements. In the report, you should have those categorized if you name them. So it's quite complicated, and it's worth playing around with the different methods. So feel free to post in the comments or on our forums if you've got any questions about this. And thanks for watching.